Good day, dear students. Today we'll be discussing about inverse Z transform. So inverse Z transform in general can be done using partial fraction method and power series expansion method. Partial fraction expansion method being the most common method that is used. So given x of Z, we would have to find what is x of n using partial fraction method. So let us start with the first problem. Given x of z is equal to 3 minus 5 by 6 z power minus 1 divided by 1 minus 1 by 4 z power minus 1 into 1 minus 1 by 3 z power minus 1, and the region of convergence is given as modulus of z greater than 1 by 3. So we need to apply inverse z transform using partial fraction method to determine x of n. So as we know, the first step is all the negative powers of z should be converted into positive powers of z. Also, we should ensure that in denominator we get the denominator in terms of factors. For example, z minus a into z minus b. So that should be the aim. So x of z equal to, in the place of z inverse, it is given as 1 by z. So substituting and then taking z as common, simplifying, we get our expression x of z equal to 3z minus 5 by 6 into z divided by z minus 1 by 4 into z minus 1 by 3. Only when we get in terms of factors, we can identify what are the poles. So now we have to apply partial fraction. But before applying partial fraction, we have to check the degree of the numerator and denominator. Here the numerator degree is 1. The numerator degree is 2 because the highest degree is 3z into z, which is z square. So degree of numerator is 2, and similarly the degree of the denominator is also 2 because it is z into z. So when both the degrees are same, we cannot apply partial fraction. Hence, the degree of the numerator should be reduced by at least 1 so that the numerator degree is lesser when compared to the denominator degree. So in order to do that, we can take this z to the left hand side. So x of z divided by z. You can see that 3z minus 5 by 6 divided by the denominator. Now the numerator degree is 1 and the denominator degree is 2. And now partial fraction is applied, a by z minus 1 by 4 plus b by z minus 1 by 3. So applying partial fractions and then substituting for various values of z, right? You can substitute z equal to 1 by 3 so that this term becomes 0. So when you substitute this, you get b equal to 2. Similarly, when you substitute z equal to 1 by 4, so this becomes 0 and you get a equal to 1. So finding out values of a and b leads x of z divided by z equal to 1 by z minus 1 by 4 plus 2z minus 1 by 3. In the given problem, the region of convergence was modulus of z greater than 1 by 3. So when the combined ROC is greater, the individual ROCs will also be greater. So x of z, the take z to the other side. So z by z minus 1 by 4, modulus of z greater than 1 by 4 because this is the corresponding pole. And z minus 1 by 3, 1 by 3 is the corresponding pole. So taking z to the other side leads to this equation. Now we can take the inverse z transform. So we all know very well that a power n u of n z transform will be z by z minus a modulus of z greater than a. So now when you compare this equation, we can see that we can read this as z by z minus a modulus of z greater than a. Similarly, 2 is a constant here. Z by z minus 1 by 3 modulus of z greater than 1 by 3. Hence, it evaluates to x of n. X of z inverse is x of n. So this will be a power n, 1 by 4 power n u of n plus 2 is a constant, 1 by 3 power n u of n. So this will be the x of n obtained by inverse z transform. We'll move on to the next sum. So in this sum, x of z is given. We need to apply inverse z transform using partial fraction method to determine x of n. So as we know very well, all the negative powers have to be converted into positive powers. So just z power minus 1 is replaced by z power minus 2 is replaced by z squared. And then take the LCM and simplify. We get this expression z squared plus 2z plus 1 divided by z squared minus 3 by 2z plus 1 by 2. However, we need to express the denominator in terms of poles. Hence, the denominator has to be factorized. So, when we factorize this denominator, product is 1 by 2 and sum is minus 3 by 2. So, automatically, when we factorize the denominator, you will be getting z minus 1 into z minus 1 by 2. Similarly, when you look into the numerator, this is z squared plus 2z plus 1, which can be written as z plus 1 the whole squared. Right? So, now we can check for, now we need to apply partial fraction, but however when we check here we are getting z squared as well as z squared both in the numerator and denominator. So we have to reduce the degree by 1. However, there is no separate z over here as in the previous case. Hence, in order to perform or reduce the numerator degree by 1, we need to multiply and divide the numerator and denominator by z. After multiplying and dividing, take this z to the other side. So we'll be getting x of z equal to z plus 1 the whole squared into z minus 1 into z minus 1 by 2. So obviously the degree of the numerator becomes 2, whereas the degree of the denominator becomes 3. So now you can comfortably apply partial fractions a by z plus b by z minus 1 plus c by z minus 2. Please put a pause on to the video and apply partial fractions, right? And then obtain the values of a, b and c. So after we obtain the values of a, b and c, we get x of a value as 1, a value as 2, b value as 8 and c value as minus 9. So when z is taken to the other side, you get a plus b into z by z minus 1 plus c z into z minus 1 by 2. So substituting the values, x of z equal to 2 plus 8z divided by z minus 1 minus 9z divided by z minus 1 by 2. So in this given problem, it is not given whether the ROC has not been specified here. So let us assume that the ROC is to the outer of the outmost pole. So we are taking the individual ROCs to also to be to the outer side. So since we have 2 here, automatically there is no denominator. That means there is no pole and the ROC is the entire Z plane. Here the pole is z equal to 1, so modulus of z greater than 1. Here the pole is z equal to 1 by 2 and hence modulus of z greater than 1 by 2. So now applying inverse z transform, we know very well that 2 is a constant. Inverse z transform of 1, ROC being the entire z plane, is nothing but del of n plus 8 into z by z minus 1. It is nothing but a power n u of n or simply u of n because the value of a is 1. So 8 into u of n minus 9 into 1 by 2 to the power of n u of n. So this will be the answer for x of n. However, we can also try to represent this x of n in another way. For example, when you substitute n equal to 0, you get 2. Del of 0 is 1. So 2 plus 8 into u of 0. U of 0 is again 1. So 2 plus 8 is 10. And then 1 by 2 power 0, u of 0, which is 1. So 10 minus 9 is 1. So similarly, we go for all values of n equal to 1, 2, 3 and so on, and the pattern repeats. For negative values of n, obviously del of minus 1 minus 2 will be 0, u of minus 1 minus 2 will be 0, and hence for all negative values of n, x of n will be 0 and it starts from positive values. So x of n can also be represented by means of its impulses. Moving on to one more example. Apply inverse Z transform using partial fraction method to determine x of n. The procedure is same. So you have x of z, convert into positive powers. So you can just put a pause on the video, work on it and obtain the expression for x of z. So once you obtain the expression for x of z, we see numerator degree is 1 and denominator degree is also 1. So now in this case, we don't have an z separately and hence we multiply and divide by z. Take this z to the other side. So x of z divided by z equal to minus 1 by 2 z minus 1 by 2. So applying partial fractions, simplifying the values of a and b, we get a value as minus 2 and b value as 3 by 2. Take z to the other side, we get minus 2 ROC, since there is no denominator, ROC will be the entire z plane, plus 3 by 2 z by z minus 1 by 2, considering it to be a causal system, modulus of z greater than 1 by 2. So taking inverse z transform, minus 2 into del of n plus 3 by 2 into 1 by 2 to the power of n u of n. Again, just as we discussed in the previous case, you can substitute for all values of n. So starting from 0, 1, 2, 3, it goes on till infinity. You will find a sequence which is obtained. And lastly, we'll see the problem. X of z equal to 1 minus z power minus 1 divided by 1 minus 4 z power minus 2. Modulus of z lesser than 1 by 2. So here you can see that the region of convergence is to the inner of the innermost pole. That is, it is lesser. So we need to find x of n. As usual, proceeding and converting it into positive powers of z, we obtain the expression z into z minus 1 by 4 divided by z squared minus 1 by 4. So this is z squared minus a squared, which can be written as z plus a into z minus a, which leads to z plus 1 by 2 into z minus 1 by 2. So numerator degree is 2, denominator degree is 2. So bring this z to the other side. So x of z divided by z. You get this. Now you apply partial fraction as usual. You can put a pause on the video and work out. Obtain the values of a and b. After obtaining the values of a and b, x of z equal to 3 by 2 z plus 1 by 2 and minus 1 by 2 z minus 1 by 2. So the poles are modulus of z equal to 1 by 2. So here it's negative and here it's positive, but radius value is always positive and hence modulus of z we always take it as 1 by 2. And since in the given question it is modulus of z lesser than 1 by 2, we take the individual ROC as also lesser than 1 by 2. So take z to the other side. When you take z to the other side, you will be getting as such you will be getting 3 by 2 z into z plus minus into z. So as usual, applying your inverse z transform, we know the formula, it is 3 by 2 is a constant, z by z minus a. So z minus of minus 1 by 2 and modulus of z lesser than 1 by 2. It is nothing but the formula minus a power n. So a power n here. So minus 1 by 2 power n. A power n u of minus n minus 1. So that is the inverse z transform of the first term, which is obtained over here. So 3 by 2 is a constant and then remaining we get minus of minus 1 by 2 to the power of n u of minus n minus 1. The same principle applies here because the modulus of z value is lesser than 1 by 2. So 1 by 2 is a constant and 1 by 2 to the power of n. So z minus a u of minus n minus 1. So here you can see that since this is all negative sided sequence, when you plot the sequence, you will be seeing that for n equal to 0, you will be getting the value as 0. Whereas for n equal to minus 1, n equal to minus 2, minus 3, you will be getting a sequence that is obtained like this. So lastly, we take the problem x of z equal to z power minus 1 minus 1 by 2 divided by 1 minus 1 by 2 z power minus 1 the whole square modulus of z greater than 1 by 2. So we need to find x of n. So here again proceeding in the same manner, 1 by 2 z the whole square. So we take LCM as here z minus 1 by 2 the whole squared by z squared. So finally we get x of z, you can simplify and finally you can take that z squared will be to the top So numerator degree will be uh, cube, and the numerator degree will be square, and the denominator degree will be, so we have to put here as z. So when you take the LCM here, this is actually z. Okay, so when this z squared goes to the top, we get z into z minus 2 divided by z minus 1 by 2 the whole square. So numerator degree is also 2 and denominator degree is also 2. So as usual, you take the z to the other side. So you get minus 1 by 2 z minus 2 divided by z minus 1 by 2 the whole square. Please pause the video and work on it. So now you can apply partial fractions because the numerator degree is 1 whereas the denominator degree is 2. So in this case, when you apply the partial fractions, you will be getting a by z minus 1 by 2 the whole square plus b divided by z minus 1 by 2. Cross multiplying and solving will lead the values of a equal to 3 by 4 and b equal to minus 1 by 2. So x of z divided by z is given. So take z to the other side. X of z equal to 3 by 4 z by z minus 1 by 2 the whole squared, and minus 1 by 2 z by z minus 1 by 2. So since in the given problem modulus of z is greater than 1 by 2, the individual ROCs is also greater. So modulus of z greater than 1 by 2 and modulus of y greater than 1 by 2. However, you can see here in the denominator, we get z minus 1 by 2 the whole square. So we know very well the formula n into a power n u of n is az divided by z minus a the whole square. Modulus of z greater than a. So here we had 3 by 4, whereas in denominator we had z minus 1 by 2. So we have to get the same a over here. So 3 by 4 is written as 3 by 2 into 1 by 2 minus 1 by 2 z by z minus 1 by 2. So this is nothing but az divided by z minus a the whole square. So when we take the inverse, 3 by 2 n into a value is 1 by 2 power n u of n minus 1 by 2 1 by 2 power n u of n. So when we simplify the values of this n, we get x of n values given over this. Thank you, students.